In this video, we're going to look at the distribution of the sample proportion. Now we know that the sample proportion varies from sample to sample. But if we know the population proportion that it comes from, if we know the setup of the population that we're taking a sample from, we can actually determine the probability of selecting a particular type of sample, or selecting a sample with a particular proportion. And this is important because if we're going to use our sample proportion to make an inference about the population, we need to know how sample proportions work when we take lots of different samples. So the size of the population that you're selecting from can actually influence the likelihood of a particular type of sample. So when we're looking at how our sample proportion is behaving, we need to also look at what size is the population that it's coming from. And the whole idea of looking at the distribution of sample proportions is to improve our confidence in making inferences using the samples, as it's important to have an understanding of how samples and the statistics that we measure on them are actually related to the population that they come from. So anyway, let's dive in and have a look. So let's start by selecting some samples from a large population. So we've got a population of 600 moths. Here's a bogong moth over here. 25% of the moths in that 600 moths have an eye on their wing, and this is an eye, referred to as an eye on their wings. If a sample of 4 moths is selected at random, what is the probability that the sample will be 75% moths with eyes on their wings? So this is very much like the sort of question that we've done before. And the sort of question that we've done before is, of course, binomial questions. The moths either have the eye on their wing or they don't. And so what we've got here is a binomial distribution where if we define success as having an eye on their wing, then the probability of success, which is our p-value, is 25%, because 25% of the moths have an eye on their wing. So we could go through this question using just binomial and the fact that if our sample of 4 has 75% of those 4 as moths, then we're talking really about what's the probability that within those 4 moths, 3 have an eye. So if we continued along thinking about it in that way, we would define X as being the number of moths with an eye on their wing in our sample of 4, and we would define our probability distribution function like this. So in a sample of 4, you could have none with the eye on their wing, you could have 1, 2, 3, or all of them could have the eye on their wing. And then we could continue on and use our CAS calculator. You can see I've already got the probabilities here, and I got those just straight from my CAS calculator. And then if I was looking for a probability of 75%, then I would be looking at 75% means 3 out of the 4, and that would be my answer, 0.047. And that's a perfectly reasonable way of solving it. If you wanted to work with the proportions though, all you need to remember is the fact that the sample proportion is a fraction of the moths in the sample of 4 moths. So we could change our x values here into proportions by writing them as a fraction out of 4. So let's go ahead and do that. And then our table would look like that. And we know that our sample proportion, p hat, is the x value divided by n. So to go from this table of values to the table of values for the sample proportion, all you do is change a little bit here at the front. Instead of x, because everything's been divided by n, it's now p hat. And instead of being the probability that x is equal to x, it's now the probability that p hat is equal to p hat. And the answers that go in here are exactly the same answers that appear in the corresponding x distribution up above. So in the exam, if you're using your CAS calculator, you can answer this question using just x, or you can turn it into proportions. Either way, you are going to get exactly the same answer. So far we know that the sample proportion is in fact its own random variable. Its value varies from sample to sample, and it varies between values of 0 and 1. It's directly related to your x values for the particular distribution. So the formula that relates p hat to the x values and the number of items in the sample is a formula that you need to know. You also need to know that for large populations, okay, so large populations, we can use a binomial distribution with n as being the number of items in the sample and p being the population proportion, so the proportion of members of the population that have the attribute that you're looking for, the characteristic that you're looking for. Now, when I say large, we're talking about a size of a population where if you took 1 or 2 members out of the population, it doesn't really change very much the chance of another member of the population being chosen. So if you've got 100 people and you choose one person, when you go to choose your second person from that group, you're now out of 99. And so everybody has a 1 in 99 chance of being chosen, which is pretty close to 1 in 100. In fact, it's almost exactly the same, except for a change in about the 4th or 5th decimal place. So large populations are populations where if you take something out, it doesn't really affect the probability of everybody else. Anyway, let's have a look at another question. We're going to look at this question here about the number of people that are born overseas. So in Australia, 30% of the population were born overseas. Now, that's slightly higher than what it is. I think it's 29.8 as at June 2021. So we'll round it to 30%. In a sample of 10 people living in Australia, what is the probability that the proportion of people born overseas in the sample, the proportion in the sample, is less than or equal to half? I'd like you to have a go at doing this question by yourself as a binomial distribution, and then come back and have a look at the solution. So just pause the video and have a go and see if you can work this out yourself. Okay, how did you go? It can be a little bit confusing if you've got a couple of values in there. So what we've got to recognise for our solution is, first of all, that we have a large population. So we're just choosing from all the people in Australia. And we have a relatively small sample size in comparison. So we're taking 10 people. And so our distribution, we can use a binomial distribution, and you guys are probably used to seeing it written as BI instead of BIN. Either is okay. So our sample proportion is distributed binomially. It follows a binomial distribution where our sample size is 10 and our population proportion is 30%, so 0.3. And then the last thing we need to interpret is, what does it mean when it says that the proportion in the sample is less than or equal to a half? So there's a couple of ways that we can interpret that. So we've got the possible number of outcomes with 10 people. Let's start just working with the people. So in a group of 10 people, you could have 0 that were born overseas, 1 that was born overseas, 2, 3, 4, all the way up to all of them born overseas. So if we wanted to turn these outcomes into proportions of the sample, then we divide all of the values by 10, and then these values here become our possible values for p hat. And then we can identify the x values that give us our p hat values of less than or equal to a half. So all of these p hat values here are all less than or equal to a half. And the corresponding x values are these x values. So what we're doing is we're turning our proportion into a number of particular outcomes in the sample. So on my CAS calculator, I would use a binomial CDF with n 10 in our sample. 0.3 is our population proportion, and our lower bound are our values for x. And they're the values for x that fit with the proportion that the question is asking us for. So then when I press OK on my CAS calculator, it spits out this answer here. So that is the probability that the x value is less than or equal to 5. And that's equivalent to the proportion being less than or equal to a half. They are exactly the same probability. So when they ask you for the probability of a proportion, just work it out using the appropriate x values. So now let's have a look and see what happens with your sample proportions and their probabilities if you have a smaller population. And by a smaller population, I mean where if you remove one member, it can affect the probability of selecting the other members. So normally your smaller populations are smaller numbers, way less than 100. So here's a small selection of lollies in a jar. And what we're doing is when you make a selection for a sample, when you take a sample, what you're doing is taking one out and not replacing it. So we're really talking about, with smaller populations, when we have a smaller population that we're sampling from, we're talking about sampling without replacement. So if I was to select 3 lollies, little teddy jellies, from the jar here, and I was looking at the probability of selecting a red jelly, then on my first choice, the chance of picking a red jelly is 3 out of 12. Once I've pulled one of those red jellies out, now we only have 11 jellies left, 2 of which are red. And so my chance of picking something has changed. And then if I get a red on my second choice and select again, the chance of selecting another red is now 1 out of 10. So for smaller populations, when we're calculating the probabilities, we need to take this without replacement idea into account. And we can do that in a couple of ways. We can do that by either using a tree diagram. That's not what I meant to do. We can use a tree diagram like I've done just up here and work out the probabilities, or we can use combinations. Let's have a look at how we do that. So if a sample of 3 lollies is taken from the jar, what is the probability that the proportion of red lollies in the sample is 1/3? Okay, so let's identify what we've got in the question. We've got a sample of 3 lollies, and we're looking for a proportion in that sample. The proportion of red lollies is 1/3. What that means is, of the 3 that we select, what is the probability that it contains one of those is red? And that means if one is red, then the other 2 are non-reds. So we can do that with a tree diagram by saying our first selection will be either a red lolly or a not red lolly. So for our first selection, the chance of selecting red, there's 3 red ones in there, there's 12 lollies in there, is 3 out of 12, which means selecting a non-red is 9 out of 12. Given that we've already got 1 red in this selection, the only other possible selections that we could make to have a sample with just 1 red in it would be a not red and then a not red. And so if we've already taken 1 lolly out to get to this stage, our next selection is out of 11 lollies, and there are 9 not red lollies to choose from. And then if we pick a not red lolly, and then we go to choose again, we need to choose from the remaining 10 lollies, because now 2 are out, 1 here and 1 here. Now 2 are out, we've got 10 left, and there's 8 of the non-red lollies to choose. And the same idea working through these branches. And so if I was to work out the probability for each of these branches and then add them all together, I would find the probability of the proportion being 1/3. Now just a couple of things to note if you are doing the tree diagram method. You'll notice that when I've multiplied all the probabilities together for each branch, the denominators are always the same: 12 times 11 times 10, 12 times 11 times 10, 12 times 11 times 10. And the numerators, which you multiply together, so 3 times 9 times 8, well, that's the same as 9 times 3 times 8, which is the same as 9 times 8 times 3. So if you work 1 out, all you need to do is to multiply this answer by how many you've got here. So that's how you would do a question like this with a small population. If you were in a non-CAS exam, you would literally work it out using a tree diagram. If you're in an exam or a SAC that allows you to use a CAS calculator, there is a much quicker way, and that is using the combinations. So let's have a look at how you would do it using combinations. Just move this up here and I'll show you that you get exactly the same thing. Okay, so how you would do it using combinations is you use, like this is my little formula thing here. These are the actual values that we're going to calculate with on our calculator. This first number here is the number of ways to pick a red. So in the jar there are a total of 3 reds and we want to choose 1. You also have to multiply that by the number of ways to pick a not red. So in the jar there's a total of 9 not reds and you need to choose 2 of them. And then you finally divide that whole answer by the number of ways to pick the sample. So you've got 12 things in the jar altogether and you want to choose 3 of them. And so you would put that into your calculator and it would look like this. And you can see when you ask it for an answer, you get exactly the same answer as what we got when we worked it out by hand using the tree diagram. So you can work it out either way, it doesn't make any difference. If you've got your CAS calculator, this is a much quicker way than doing this, unless you recognise the 3, the 9 and the 8 and the decreasing denominator. So our final answer is that the probability that the sample proportion is equal to a third is 27 on 55. So let's have a look at an example. A committee of 5 students is to be selected from a group containing 8 Year 12 students and 12 Year 11 students. What is the probability that the committee is made up of 40% Year 12 students? Okay, so let's have a think about our committee. We have 5 members. Of those 5 members, we need 40% to be Year 12. So what's 40% of 5? I hope you're yelling at me that it's 2. It's 2 because we take 5 members, we multiply that by 0.4 if you like. 5 times 0.4 is equal to 2.0 and that's 2 people. So we're after the probability that 2 of those people are Year 12s. So let's do this. I don't want to do a tree diagram with 5 people, so let's do it using combinations. So our combinations go. We need to select 2, so let me just put our C's as a C times a C divided by a C. And on the top we need 2 Year 12 students. Let me just get the right colour. 2 are Year 12s. And we have 8 Year 12s. 8 Year 12s to select from. So if we've got 2 Year 12s, that means our other selection is going to be from the not Year 12s. So we need to have a group of 5. So we're going to need 3 Year 11s and we have 12 Year 11s to select from. And overall, from the whole of the population, we have 20 people all up. So we've got 8 Year 12s and 12 Year 11s. So altogether we have 20 people in our population and we need to make a committee of 5. That's our sample size. So if we go ahead and calculate that using our CAS calculator, we get 0.3973 as our final answer.